education and training institutions or colleges. And this backlog, we have all seen it every year, each and every year come January, we will see our kids with all those bags sitting outside university residences or university admin blocks seeking accommodation. That has contributed into this. This is the challenge that we are having. It is estimated that around 300,000 beds are required at the university level. So that's a huge number if you look at it in terms of the backlog that it's there with regards to accommodating our students. And we as we know that the government recognizes the importance of expanding this access to affordable rental as well as social housing for low and middle income households, given the allocation of housing budget over the years. And recent research and case studies have demonstrated that alternative building technologies have proven effective in terms of accelerating delivery timelines, reducing life cycle costs, and improving quality in the delivery of housing. These technologies are also essential in cutting the building industry's carbon footprint and protecting the natural resources and the environment while providing climate resilient solutions. So this webinar will explore the role of alternative building technologies in scaling up the delivery of housing. And this will be done through the extensive definition of some of the tried and tested alternative building technologies on how they are possible solution in addressing housing delivery challenges, including their benefit and limitations. The webinar will also focus on practical possible considerations for government in closing the housing backlog. So the role of alternative building technologies, which is today's presentation, will be delivered by Dr. Coralie van Reenen to allow for enough time for questions and answers. We will allocate around 30 to 40 minutes to Dr. van Reenen to take us through her presentation, and then we will then open it up for questions and answers after her presentation. So our speaker has a comprehensive resume on this subject, which we will not be going through it today, but I would like to highlight that Dr. van Reenen is a professional architect and research group leader of the Infrastructure Innovation Research Group at the Council for Scientific and Industrial Research, which we all know as CSIR. And her research considers health, well-being, and sustainability in the built environment with a focus on driving the digital transformation and performance monitoring. She is active in promoting innovation and transformation in the human settlements and public infrastructure sector. As a Green Star accredited professional, Dr. van Reenen has a thorough understanding of the principles of sustainable design in terms of social, economic, and environmental sustainability. She has experience in development of norms and standards, design guidelines, and policies. So without any further waste of time, let me welcome Dr. van Reenen to take us through her presentation. You are most welcome, Doc.
Thank you very much for those words of introduction and welcome. I'm very excited to be here today. ABTs is one of my favorite topics. So thank you for inviting me to speak. And my intention today is to convey a good understanding of innovative building technologies so that we can make informed decisions regarding our response to our infrastructure needs. So I'll just be going through defining what exactly are innovative building technologies, what do we mean by that, what are the different types, why would we use them, what are the benefits, looking at the regulatory context, then some application in South Africa, and then we'll conclude and we can take questions after that. So starting off with the definition. Innovative building technologies refer to construction methods that don't use conventional brick and mortar, concrete or steel as the structure or infill elements. This is also often referred to as alternative building technologies or emerging building technologies. It's really all the same thing, so please don't get too confused if people use different words in the industry. So you can roughly divide IBTs into 4 different types. Panel systems, framed systems, and block systems. And I'm going to unpack each of these in a bit of detail. And we'll see that there's a vast variety of IBTs, so it's not just one thing. Starting with panel systems, under the panel systems we get 2 types of panels, a dense homogeneous panel or composite panels. These panels usually come in sizes of about 1.2 to 2.7 meters, so they are modular, and the height of the panel is then typically the height of a normal wall. The dense homogeneous panels usually are made up of some kind of precast concrete, which is typically not conventional concrete, but includes polystyrene beads or air pockets or fibers or other materials to make it lighter. The lightweight composite panels are sometimes called structural insulated panels or sandwich panels because they usually consist of something like polystyrene or polyurethane foam in the middle with some kind of board on the outside, like fiber cement board or magnesium oxide or chromadeck metal sheets or wood to then make the outside skin of the sandwich. And here are just some images to give you a better idea of what we're talking about when we talk about panel systems. Then moving on to framed systems. These systems consist of a framework of timber or steel to provide structural strength. And then the frame is clad with some kind of panel or similar material with some kind of insulation in the middle. So the strength comes from the structure itself, but the structure is normally prefabricated. You can see in the bottom left here, it's almost like panels of structure, which are then clad. So they're made off-site and are brought to site to be erected on-site. Then the third kind is the block systems. These are like bricks, but they're usually, not always, much larger and made out of some kind of special concrete that is lightweight. The examples here show plastic blocks up here in the right-hand corner, earthen blocks, which are made in a press, or this example here on the left-hand side is a hempcrete block. But there are many, many different types. These are just some examples. And then the fourth category is in situ or hybrid systems. These are usually cast-in-place systems. Very often there is a lightweight non-structural core or shell, perhaps made out of polystyrene, which is then filled in with concrete or covered with some kind of concrete. An example is a system with a solid polystyrene core to make up the thickness of the wall with a steel mesh on the outside covered with a structural plaster or shotcrete. 3D printed walls can also be put into this category, being in situ, although they could also be in a category of their own. And it's quite a new technology that is emerging at the moment. So you can see there's a wide variety of alternative building systems, each with their own unique characteristics. So we do need to be careful about generalizing about IBTs. These images here are just a couple of examples of projects that have been done in South Africa over the last 15 or so years using each of these different types of systems, just to give a quick overview of how they are used in reality. But now the important part is the why. Why would we use innovative building technologies. What's wrong with business as usual? And what are some of the benefits of ABTs? Now, just to quickly answer the question, what's wrong with business as usual? Not necessarily anything. So bricks are fine and concrete is fine. But I think it's good to have options and to know the benefits of different systems, because not everything is right for every situation. When we come to sustainability, I'll comment a bit more on bricks and concrete. But there are two main benefits to using innovative building technologies. The one most commonly cited is speed of construction, and the other commonly cited advantage is sustainability. Now, I want to unpack each of these so that we make sure that we have a proper and common understanding and realistic expectations of the supposed benefits of ABTs. I say supposed benefits because industry tends to lump all ABTs together and make these claims, and they're not necessarily all true of all systems. So we'll look at these one at a time, starting with speed of construction. As I was explaining the systems in my previous slides, I'm sure you could already start imagining that with something like a panel system, a full 3.2 square meters of walling is automatically put in place just with tilting up a panel, as opposed to laying 168 bricks. So panel systems particularly are especially lightweight and can be easily carried by one or two people on site. You can see in the image down at the bottom, the one in the middle, they've just lifted up that whole gable wall on a lightweight scaffolding and are erecting the building there. So the lightweight and covering a lot of surface area at once is one of the advantages that gives the ABTs the name of being quick to erect. We need to carefully consider sweeping statements about the speed of construction, because it may not always be the case depending on the size of the building. Let's say, for example, it takes 4 bricklayers one day to build the walls of a 40 square meter house. That's not unrealistic. And it takes 4 operators one day to build the same walls with a 3D printer or almost any of the other systems, maybe just using different skills. What usually actually takes time in housing projects is the earthworks, foundations, surface bed, casting the slab, waiting for all of that to cure before you can build on it, the installation of windows, doors, roof, electrical fittings, wiring, plumbing, and finishing. And in most of the ABT systems, not all, these elements are the same and take just as long. So no matter what you build your walls out of, you still need to install the electrics and the sanitary fittings and the roof and all of that. So they don't necessarily make the entire process quicker, but they are quite quick to erect. In some cases, these elements can be pre-installed in the factory. This then does decrease construction time on site, but it requires a higher level of coordination than we are accustomed to. So when you build with brickwork, for example, each brick is the same and it doesn't matter where it goes in the building. And if you get to the corner and the last brick doesn't fit, you can just cut it off. But if you have panels with predetermined and pre-installed electrical outlets and windows, etc., it really matters which panel goes where in the building. And this is not difficult. All I'm saying is that it needs to be considered upfront because coordination is required on site. When it comes to larger structures, using alternative systems can make a significant difference, as opposed to the example I used of a 40 square meter house. If you have a large double volume hall or a multi-level student housing or something like that, a framed structure that is pre-designed at the factory is lightweight and can be erected fairly quickly on site and then clad with lightweight materials. The same structure in bricks will require hundreds and thousands of bricks, often as infill between concrete columns and beams that are cast in place on site and need to cure for 28 days. Buckets of mortar and piles of bricks need to be handled at height. And all this can indeed take very long and comes with risks. So in such a case, a suitable ABT system can certainly save time and make the whole construction much quicker. Another big question that arises is cost. Is it cheaper? And I'm mentioning this on my slide about speed of construction because time is money. The answer is usually, in terms of material costs, there's not a lot of difference between conventional construction and construction using alternative technologies, but the saving is in the time. Then another thing to consider with speed of construction and the advantages of these systems is quality control. Prefabricated elements means that everything is pre-cut in the factory, and there's supposedly less chance of things going wrong on site, which means it can be erected more quickly on site. However, as I mentioned previously, we do need to just remember that a lot of the time in a construction project is not in building the walls, it's in the earthworks and foundations and all of the fittings. And as I said, the type of building also needs to be considered. Then if we move on to sustainability, there's quite a lot to unpack here. And I'm listing these in a generalized way. Again, please note that these sustainable benefits are not necessarily applicable to all the systems. So you may have noticed as I was explaining the different categories and types of ABTs that many of the systems are lightweight. And the reason that they are typically lightweight is because they usually include insulation materials such as polystyrene. And it's this high insulation value that has led to the systems being labeled as sustainable, because high insulation translates to low energy because you're not heating and cooling the buildings as much. This, of course, assumes that we are heating and cooling our buildings using dirty energy, and thus there's a high carbon footprint associated with that heating and cooling. And if we can reduce the heating and cooling load, then we are reducing the environmental impact ultimately of the building. So these systems do typically have a superior thermal performance. A lot of systems, particularly frame systems, are predominantly dry construction. And this has a sustainability benefit to it because we're using less water on site, and water is precious. Even some of the block systems, not the panel systems, are made to fit together without mortar. So they're interlocking blocks, which means there's a significant water saving during construction. However, a caution here is that many of these systems rely on an outer layer of plaster to achieve water penetration requirements. So while the system itself might meet fire resistance requirements and structural requirements, very often the water penetration requirement can only be met by plastering over the system. And then that plastering does require water, so we can't necessarily say that these systems are completely dry and water-free. Then the next big benefit in terms of sustainability is reduced construction waste. We know that we're trying to reduce the amount of waste that goes to landfill, and if we can reduce construction waste, that's a big win. Since many of the systems can be manufactured off-site, there's less construction waste on-site. And we trust that the waste that is generated at the factory is reused or recycled in some way. But the fact that many of these are prefabricated helps a lot with construction waste. And even in terms of the block systems, because the blocks are typically larger, we can work in a modular fashion and usually get away with cutting and having less waste. And then the big one that we want to talk about is the lower carbon footprint. Many of these systems claim to have a lower carbon footprint than conventional building methods. And this one is dubious. I want to maybe do a bit of myth busting here. We need to be careful. Cement and bricks have been given a bad name in industry for having a high carbon footprint. And this is due to the energy required in manufacturing. And the industry seems to then assume that anything that is not cement or brick is good. But we need to question this. Firstly, a lot of the cement and brick manufacturers are working very hard to reduce their carbon footprint and use clean energy. Energy isn't the only component. There are other processes that are unavoidable in making clinker that do generate a lot of greenhouse gases. But yeah, we do need to just consider that. And then we need to make sure that what we're claiming or what we're hearing is measurable and validated. There's almost no data supporting claims that innovative building technologies have a lower carbon footprint. In the literature, there is, and I do believe that on the whole, one can say this. But a recent study of all the Agromar certified products in South Africa, and that is plus minus 100 walling systems, only one of those products had a certified claim about its embodied carbon, and 9 made unquantified claims. So they said that it had a lower carbon footprint, but they didn't give any numbers to that. The rest make no claims. So we need to be careful, and that's, I want to reiterate, it's not to say that these things that we've been hearing about a lower carbon footprint are lies. We just need to make sure that we're not generalizing. So we need to look at the data for each system. Furthermore, even though there might be no cement in the product, as I mentioned previously, many of these systems rely on plastering to gain their water penetration requirements, and that plaster is often cement-based, but that plaster is often not counted in the embodied carbon of the material itself. So again, we just need to be careful about these claims. Generally, one can say that ABTs are faster to construct and sustainable, but we do just need to be careful how we quantify that. Then we're going to move on to the regulatory context, because this is often cited as a barrier to using innovative building technologies. Our policies don't support it. Our building regulations don't support it. Our national building regulations are very good, and they actually do allow for alternative construction. And our national departments are all generally supportive of innovative building technologies. They want the industry to be using innovation to make things better and quicker and so on. So I want to talk a little bit about the national building regulations and how they are supportive of innovative building technologies, and indeed there is no barrier. The building regulations aim to ensure that buildings are safe and fit for purpose. Provides minimum uniform standards. We can always exceed those standards. And the national building regulations are implemented through the South African National Standard number 10400. SANS 10400 provides methods to comply with the national building regulations. So the national building regulations will say your building must not fall down, and the SANS 10400 will say how you can design your building so that it doesn't fall down. So it's the application of the building regulations. The NBR uses conventional construction as a baseline, but it allows for compliance by any other method if supported by evidence. So here in the SANS 10400, they talk about deemed to satisfy requirements. These are the requirements to meet the performance requirements of the national building regulations, and it provides a verification method by which it may be confirmed that the requirements are being met. And it says here in the second part of clause 4.2.2, the deemed to satisfy requirements presume that if the owner adopts one or more of the following methods, the functional regulations will be satisfied. So there are 3 ways that you can meet the regulations. The first is you adhere to the prescriptive requirements provided in the SANS 10400. Now, those prescriptive requirements are like a recipe, and the recipe assumes that you're building with brick, concrete, and steel, so conventional building materials. And if you follow the recipe, your resultant building will comply with the national building regulations. So that's the easy method. Doesn't require a lot of thinking because you just follow the recipe. If you don't want to exactly follow the recipe, but you still want to comply with the building regulations, your ultimate building must still stand and be fit for purpose. You can build out of any material you want to, provided that a competent person prepares a rational design and signs it off. For example, an engineer would say that your beams can span this distance. There's a set distance in the prescriptive requirements, but if your beam needs to span further, you need an engineer. And the same applies if you're using alternatives to the conventional building methods. So you can appoint a competent person to basically verify your design. And then the third method is to erect a building in terms of an Agromar certificate. So I'm going to talk now a little bit about what an Agromar certificate is and what it means. And I want to emphasize that an Agromar certificate is not the only way, because you can also, that middle method, get a competent professional to sign off your building. So Agromar South Africa will test and validate any building product that does not have an SABS standard against which to verify its performance. Agromar is an entity of the Department of Public Works and Infrastructure, and they will perform a series of tests. I've listed 7 tests here that they'll test your product according to. So they will test that it's suitably fire resistant, they'll test structural performance, water penetration and rising damp, thermal performance, condensation, acoustic performance, and durability. So if a product passes all of these tests, it's deemed fit for purpose. A certificate is then issued to the manufacturer, and that certificate is valid for 3 years and needs to be renewed every 3 years to make sure that we are still in compliance. Okay, so that is Agromar certification. Another government entity is the National Home Builders Regulatory Council, and they also support the use of innovative building technologies. Granted, this is now limited only to home building, but they've developed guidelines to help the industry to understand and comprehend how to build with these innovative building technologies, because it is a little bit different. And we found that one of the barriers to application is this know-how. There's a hesitancy in the market because we don't quite know how these things perform, and so we rather just go with what we know and what we trust. So that covers some of the regulatory context regarding innovative building technologies. So how does this now apply to us in South Africa, given what we've been presented with so far? Given the claim of speed of construction and sustainability, it seems that IBTs are a potential solution to our urgent need to provide housing, as well as other public infrastructure, such as schools and clinics, while responding to climate change. Recent increases in disaster events, such as flooding, also raise the question as to whether IBTs can help us provide rapid replacement or temporary housing where homes have been washed away. So it seems that there is a place for IBTs in South Africa. IBTs can certainly assist in addressing these infrastructure challenges, but it is very important that we make informed decisions and understand the potential shortcomings to make sure that we make good, well-considered decisions, because not every system is suitable in every situation. And this is where the CSIR has a big role to play. The CSIR has extensive knowledge and understanding of how these systems work and the pros and cons of the different systems. The CSIR has developed a decision support tool for the NHBRC to assess the suitability of Agromar certified systems for housing construction. Now, because they are Agromar certified, most of them are suitable, but they might not be suitable in every single scenario. And so this decision support tool, it's an online tool available on the NHBRC website, helps a designer to pick the relevant IBT based on location and other site-specific criteria. such as lead time, flexibility, is local labor requirement, is local labor available, and is the system easy to be translated and used by local laborers who maybe aren't specifically educated in that system. So this decision support looks at all of those things to help pick the right Agromar certified product. It is only limited to the Agromar certified products, and there are 100 or so on the market at the moment. The CSIR has also developed a costing tool for early decision support for student housing, which was mentioned in the introduction. And it looks at the cost of innovative building technologies over the full life cycle of the building, and builds that into the cost right up front so that decisions can be made. The CSIR also presents training on how to use these materials. We've done a lot of pilot studies on housing as well as other kinds of public infrastructure, looking at how these alternative construction systems work in real life and what are some of the shortcomings, pros and cons. The CSIR Infrastructure Innovation Research Team is also currently conducting research and erecting experimental buildings on the test site at the CSIR to evaluate the merits of different innovative building technologies in the face of disasters such as flooding. And we've established criteria in addition to those of the IBT Analyzer tool to see which of these products are best for very rapid construction, as in an emergency situation. And there we look at things like it must be prefabricated, there must be mechanical fixing, no wet works and no earthworks. So this is just some of the research that has been done to help us mainstream these technologies and use them in the right way, in the right place. And the CSIR also provides a lot of implementation support. 2 examples are both in the Eastern Cape and the Koffenbarber Science Centre and the Lambe Multipurpose Centre and Housing, where a selection of 4 different innovative building technologies have been used in these different products to provide decision support and see how they roll out. So I'll conclude here by saying that IBTs are an option, and there are lots of options. And I think there's a lot of richness in having options. The drawback is then choosing the right option. There's a lot to consider in each system, and each site is unique. So there's not going to be one product that is right for all sites in South Africa and for all types of buildings in South Africa. So we do need to make considered decisions. And we as the CSIR are here to support. We'll be very happy to provide client advisory services or to just give a word of caution here and there. And with that, I want to thank you for your time and your ears, and I welcome questions on my presentation. Thank you very much.
Thank you very much, Dr. van Reenen. That was a lovely, insightful presentation. I think we've gained a lot in terms of understanding these innovative building technologies. So I would like to open it up to the platform for questions or comments. If you've got a question or comment, please raise your hand, then we'll recognize you. Or you can also use our chat, then we will also respond via the chat component. Any questions? I see the screenshot. Okay. Oh, I see. Grace, you can unmute and come in, please.
Thanks very much, Chair, and thank you, Dr. van Reenen. That was a fascinating presentation. I'm particularly interested also to hear your thoughts on the sort of cultural acceptability of IBTs. Do people like them? Do people see them as something that they would want to live in or use as a building my comment stems from interest in sort of alternative sanitation technologies, which are not particularly welcome in some areas. And I just wonder if you have any thoughts on that. Thanks.
Great stuff. Wonderful. Can I also then take, is it Bebet? You'll pardon me, madam.
Thank you. Your pardon, sir. I'm busy.
Okay.
Yeah,
Thank
just two or three questions. One is the lifespan of this building. How would most of the technology that we've spoken about, how long would one expect them to stay as quality for? We tend to expect brick and mortar to last a very, very long time. So how long would we expect this one to last for?
Sure.
And I'm looking at the panel and I'm trying to compare it to the steel or tin houses that many tend to use in informal settlement, and whether there's something there to compare, or whether you have also studied that and whether you could have comments about that one as well. Thank you.
Thank you very much, madam. I see we have, okay. Dan, and then Tembela and Stefan. Then you can come in.
Good afternoon. Am I audible?
Very much so, sir.
Thank you very much, and good afternoon to everybody. And much appreciating the input from the researcher that has been made. Mine is I'm an old certificate holder of alternative building technology, and have gone through the unfortunate frustrations whilst this technology has been over time been affirmed as an intermediary on a catch-up on bottleneck projects, on the student accommodation, so forth. But this becomes a year-on and year-on research findings, but there's no pragmatic solution forthcoming. Up to date, I've been monitoring Public Works, who is a custodian currently now of these certified solutions, have not even gone out and created opportunities. Human settlement in itself has been a root cause of failures. In the last session we had with Agrima SA, it was around May this year. And in it, we found disappointingly that Agrima SA CSIR is merely a tool for academic advancement, but not about pragmatically and soliciting the enabling of use of certified solutions as the one that I've got. And this is just but a comment, but wanting to seek from yourself as a technical advisory center, to what extent are you really involved with, at the presidential level, infrastructure project initiatives, with Public Works, human settlements, and the municipalities in respect of having to give some form of ratio percentage of opportunities? Because we've got solutions that has been proven acceptable by societies, particularly here in the Eastern Cape, which is most rural, where I'm operating at. So that is my issue of concern and clarity I would like to see about your role you are playing in advocating and advancing the alternative technology solutions. I thank you.
Thank you. Thank you. Thank you very much. Then, Tembela?
No, thank you, Chair. I think my question has been partially actually covered, which was really focusing in terms of the quality or the durability of the ABTs, and maybe it's a comment also to say that maybe on my previous work we once had a study that was also focusing into building schools, and we were looking into the community, of which the community really didn't accept that ABTs, and it was a kind of maybe not well given an information about this type of an alternative. And it was a kind of a pushback that this project, we have a problem in terms of how long would it last? And we have schools here that have been here for 100 years, and looking into the lifespan of ABTs, usually they're a bit shorter. And I don't know, maybe there is any. So the question is there any type of community engagement in terms of understanding the acceptability of these particular alternatives? Those are one of the question. And also the second one is that it might, this particular alternative, it might be, I think maybe at some point it might be look cheaper. But if you end up checking in terms of how long does it last compared to the brick and mortar, don't you think maybe it might end up being expensive to the point that, if I make an example, a school can cost, a school that can be built for 100 years can be there for 100 years, and this ABT can be there for 20 years, and then maybe you have to do something else, and then the maintenance cost, and it won't end up being even more costly compared to the brick and mortar project. Thank you very much, sir.
Okay, wonderful. Can I allow Dr. van Reenen to respond, because I see there are so many hands that are raised. Then we'll start with Stefan, and then Jennifer and Lerato when I come back. So Dr. Stefan, if possible, you don't mind, we would also like to see who we are talking to. Some of us have not seen you, Dr. van Reenen, so if possible, then you can just turn on your, wonderful. Thank you very much. You can go
This is what I
ahead
look
and
like.
respond.
All right. Thank you for the questions. All good questions and common questions. So I will try to take it from the top regarding social acceptance. It's a valid question, and I know especially with the alternative sanitation, it's very valid, and education is required in most cases to help people to understand that the system is of equal quality. And I'm saying that very generally, whether we're looking at off-grid sanitation systems or building systems. What we do find helps significantly, and we've got case studies proving this, with that social acceptability, because people are hesitant, they don't trust things that they don't know, is co-design. And co-design is something very different to community participation. I know that for public infrastructure projects, we're supposed to have community participation. And often, I'm going to make a little bit light of it, but often that is the architect's done the design and made some very beautiful pictures. And we, on a Saturday morning, go to some community venue and we show beautiful pictures of what we're going to do. So we've shown the community, and we call that informing the community, we call that public participation. Fine. Co-design is something very different. Co-design means you're designing with the community. It's a whole different methodology, but it works. It's extremely effective. It takes a little bit of extra time, but it means going into the community and sitting with the people who are going to be using the school, living in the houses, and say, look at these 5 different kinds of building materials, take samples with you. Which ones do you like? If we were to design with this one, what would you like it to look like? It's a workshop. It takes a lot of hands-on effort, but it's been very effective in getting real community buy-in and trust of the systems. I know some of you will have heard of the knock test. I hate the knock test because it's been around for as long as I've been around, and I've been around for a while. The knock test is people say, yeah, but when I knock on it, it sounds hollow. I want it to sound like solid brick. I have a suspicion that that might be a bit old-fashioned. So I'd love to redo that study with a younger cohort. But it is a reality. It looks or sometimes feels prefabricated, and we do need to get over that because we have negative connotations with prefab buildings. We had prefab classrooms. Prefab houses are generally hot and uncomfortable and temporary, but end up becoming permanent. So yes, a good question around social acceptance. There are ways around it. Some of the systems are easily accepted, like the block systems. They're bricks, they're just made out of something else. And it also depends on your market. I mean, a lot of these materials are used in very upmarket lodges, right down to, you know, your low-cost housing, and you get a different response from different markets. Then there was a question about the lifespan. Agromar certification tests for a lifespan of, I can't remember, it's 40 or 50 years. It's not less than 40. So let's say 40 as a minimum. So that's the minimum lifespan. That doesn't mean on the day it turns 40, it's going to fall down. It just means it will last for at least 40 years, which is a fair lifespan. And we generally consider buildings to have a lifespan of 40 to 50 years, even if they're built out of brick and mortar, and will indeed last longer than that. There was a question, Pavetse, about comparing to steel houses. I wasn't quite sure what the question was. Maybe you can just clarify your question in the chat, and then I'll come back to that one. Don, you asked about, what are we doing to help mainstream and get the manufacturers of these IBTs into the market? I hear you, and we're actually working on that. Just yesterday, I was part of a commission at the National Construction Summit, and there was a whole commission just on how is the Department of Public Works going to bring innovation into their buildings. They're on it. They want to do it. But just as much as we here in this room are asking, what about social acceptability? They also are. They're also asking about, can we trust it? There are a lot of questions that we do need to get over. But they are wanting to use innovative technologies. And the Department of Science, Technology and Innovation has actually commissioned the CSIR with a project to mainstream these innovative technologies. So we are extremely deliberately working on bringing these technologies to market. The Department of Science, Technology and Innovation has funded a number of projects to implement these alternative technologies in human settlements as well as in other contexts, to, as I said in my presentation, to see how does this work? Can we trust it? What can we learn from it? Pilot studies so that we can make our mistakes and learn, and then take that to industry and say, this is how you should be doing it. We made a mistake, don't do this, do it like that. And those have been very successful projects in terms of pilots, and we will publish on those. And so the message is we are being deliberate about mainstreaming these technologies. Tembele, you spoke about durability, and I think I've hopefully covered that. The Agromar testing tests for durability, and they should be durable for at least 40 years. Maintenance costs are really comparable to a brick building. As I said in my presentation, most of these structures are plastered. If you ding your plaster, you need to patch it with polyfiller and paint it. You do need to paint your brick building if it's plastered every couple of years in any case, and the same applies. So there's not a lot of difference. And we have in the student housing costing tool built that kind of durability costing into the overall costing as well. So we need to be maintaining our buildings regardless, and the cost is not very different. I think I've covered all the questions we've had so far then.
Yes, you have. Thank you very much. Stefan, can I take you? And then Jennifer. And
Thank you,
Gerard.
Chair. Good afternoon, Dr. van Reenen. If I can pick your brain for two things, please. If we move to an IBT, whichever setup, but I think it will be multi-pronged, if we move to adopting such a approach, is there a pipeline for the building material that is required? So practically speaking, I think the Americans use a lot of wood in their building. Do you anticipate that South Africa would have a pipeline for whichever material on whichever option would be used? And then secondly, in terms of the section in your presentation where you talked about sustainability and energy costs, and so forth. Do you see the market gradually moving to things like where houses are measured on air tightness and so forth to bring down heating and cooling costs and so forth? If I could just get a broad overview from you. Thank you.
Thank you very much, Stefan. Lerato? Oh, it's Jennifer, then Lerato.
Thank you so much, Chairperson. Good to see you, Dr. Van Reenen. Well done. The biggest advocate for innovation, building technologies. Coralie, you know, as I was just also looking through this topic, I actually found that there was another area that we don't often talk about, and that's the whole area that comes before the building. Like if you look at the GIS models, aerial monitoring, AI monitoring, communication technologies, beneficiary data, because that's the technology that comes before the panels you've told us that go up. If you look at, in our case, like human settlements, we're automating the whole grant management system. And in order to see how many, let's say, houses will be building technologies will go up. So where do you package that? Just curious about that, because I was thinking that that's also a type of innovation building technology. It's just that it's before the wall panel begins to go up, because we also have the whole GTAC technology, which I would think is also part of the innovation building technology, because it's a technology that comes before we actually put up the panels and we put up the walls and things like that. Just wanted to know your take on that. Otherwise, great presentation.
Wonderful. Thank you very much, Jennifer. You know, I want to abuse my powers and request, maybe there was a question from Dan with regards to where is human settlement standing in this discussion. Would you be able to give light or your understanding? I know it won't be an official, but your understanding in terms of where you are with regards to the adoption of these technologies as human settlement.
Sure, just give us a separate webinar. Then we will take you through.
Okay.
Yeah, really, give us a separate webinar. We'll
no.
And we'll take you through even the last question on the materials and things like that. Just give us a separate webinar, because we also need, we also need 2 hours to take you through that. Well,
wonderful. Nobuntu, you heard that one. So challenge accepted. We'll do that. Lerato?
Thank you, Chair, and thank you, Dr. van Reenen. My question relates to the materials used in IBTs. What proportion of them are locally produced, if any? And then the other question that I had, just out of curiosity, the overall impact of these technologies on construction labor, if you guys have done any research looking at that. Thank you.
Wonderful. Thank you very much, Lerato. Doc, over to you.
Thank you very much for that set of questions. I'm going to first address the question in the chat, which I missed earlier, regarding whether steel or zinc material used in most shack dwellers is comparable to any of the ABTs. No. Well, yes and no. It depends how you define an ABT, because an alternative building technology is anything that's an alternative to what we're used to using, and so steel and zinc is an alternative. But let's define, when we talk about ABTs, to something that is Agromar certified or could potentially be Agromar certified. So something that is performing as per the building regulations. And in that case, the steel and zinc that's used in most shack dwellers, as mentioned here, it's not comparable. The insulation value is very poor. And so it gets very cold in winter and very hot in summer. Now, all of these IBT systems are designed for comfort. Comment on fire response. So again, most that are all that are Agromar certified and most that aren't will comply with at least a 30, if not a 60-minute fire rating, which means you've got 30 minutes to get out or before the whole thing burns down. Fire management. Okay, I think I've covered most of those. It comes down to these products do need to be tested and verified. We don't just take anything and say it's fine to use. We need some kind of verification before we use them. Then, Stefan, you asked about, in moving to adopt, is there a pipeline for materials? Yes, there are around about 100 certified products that are ready to go. I'll qualify that a little bit though, and it relates to a lot of the costing questions as well that are coming up. Most of these innovative building technologies, it's startup companies. And so they manufacture according to demand. So if someone says we need 100 houses, then they manufacture. And that is costly because they don't just have the materials. I mean, the Cora brick doesn't worry about the demand. They know there's a demand. They make bricks all day long, all year long. And so bricks can become cheap. It's a supply and demand and economies of scale issue. So as these technologies become more mainstream, they will become cheaper because the demand is going to change. And there is a pipeline of these technologies. There are a whole lot out there that are approved manufacturing, but they're not manufacturing at scale because the demand isn't there at scale, but they're there. In terms of sustainable energy and airtightness, the notion of having airtight buildings is something that the Green Building Council and researchers adopted from European standards. South Africa, we don't really want airtight buildings. We want naturally ventilated buildings. If we are using mechanical heating and cooling and ventilation, then we do want airtight buildings because it can reduce the efficiency. If I've got an air conditioner on in my office and my window is open, my aircon is going to work very hard to maintain the temperature because it's fighting with the outdoor air that keeps on coming in. So in that case, airtightness is relevant. If we are limiting the scope of this discussion to human settlements and typically low-cost housing, airtightness isn't really an issue because we're generally not using air conditioning in our houses. So nothing, I'm a researcher. There's not going to be a straight answer to anything. The answer is going to be, it depends. All right, then Jennifer, you spoke about all the things that need to happen and the potential innovations before we even get to choosing a building material. You are quite right. And I mentioned earlier that the DSTI has commissioned the CSIR to mainstream technologies. In the context of this conversation, I was referring to these innovative building technologies for building walls. But the scope of that project, and it is endorsed, and Human Settlements Department is a key partner on that project, is any kind of technology that's going to help us deliver better human settlements. And so these type of digital tools, GIS, all of those technologies and innovations that can help us deliver better human settlements are part of that project. And how can we make that more effective? And innovation is not just a technology. It's also sometimes just the way we think. It can be policy changes. So there's a lot of work to be done around beneficiary management and things like that. 100%. Lorata, you asked about materials and what proportion are locally produced. Very good question. We don't really know. Again, we can't generalize because there are hundreds of these systems. So I can't say they're all locally produced or all not locally produced. There's some that are locally produced, there's some that aren't. And the range of types is so vast that I can't give one answer. If I'm looking at an engineered timber building, that can be 100% locally produced because we've got timber supply in South Africa, and our climate is such that we can increase our timber supply if need be, if the demand is there. If we're looking at sandwich panels with magnesium oxide board on either side, those magnesium oxide boards come from China, and there's an embodied carbon cost to bringing them to South Africa. So there's not a straight answer to that one. I think I've covered, oh, there's a question about the impact on construction labor. It depends, but in general, there's not a lot of impact on construction labor, where the impact is maybe in skills. An extreme example would be comparing bricklaying to 3D printing, because bricklaying is quite easy, relatively. Good bricklaying is not easy. I've laid a lot of bricks and it looks terrible, but I know how. You know, you stick them on top of each other with mortar in between. 3D printing requires a bit of a different skill, but it's quite easy to transfer those skills. It's not high level of education. So you could take bricklayers and turn them into 3D printer operators. A lot of the other systems, a carpenter or a bricklayer, anyone who can use his or her hands can make these systems work. So, and they generally use the same amount of labor as for conventional construction.
Wonderful.
I think that covers that set.
Thank you very much, Doc. Doc, I would really like you to also look at the question from Portia on the chat while we take Vivek this side. Vivek?
Hi, Doctor. Two questions, please. Thanks, Chair. The first one is, we say that there's limited uptake of alternative building technologies in our country, yeah? Now, so the question goes along like this. If we had to look overseas, I mean, how much use is there of these technologies overseas? I mean, the example that comes to mind was during COVID. The Chinese had put up a hospital that went up incredibly quickly, and that example sticks in my head. The second question, I think it's, well, I'm not sure how to ask this, but it goes along like this. The capacity or capability of our building industry. Now, if I go along with the CIDB ratings, right, there's from 1 to, I think it's 15 or 9. Yeah. So there's a whole range of contractors within there, of different, call it capabilities, for want of a better word. The ability of these contractors to use this technology, what does that look like?
Okay.
Thanks, Chair.
Thank you very much. Thank you, Vivek. Doc, I think that was our last contribution. Then you can go ahead and then respond. Thank you.
Okay, thanks. I'll take that question and then I'll look at Portia's question in the chat. So regarding uptake overseas, I don't actually know. I hear you about things like the hospitals that were put up very quickly during COVID. We also did a lot of things very quickly during COVID. So we maybe just didn't get as much airtime. Something that, just looking at something like the hospital example, that could affect uptake here in South Africa is procurement. And I don't want to say our procurement policy, because our procurement policy does not provide any barriers, but the way we set up our tenders and the way we evaluate our tenders, we want it to be easy, and it's very easy to evaluate tenders based on brickwork, because then you're comparing apples with apples. And so if you want a quick evaluation, you just make a tender for brickwork. But if you make a tender for, we want this to be the resultant building built out of anything you want, prove to us that it works, the evaluation process becomes hard work. So we need to provide assistance there, and we are doing that as well as part of our drive to promote the uptake. We also, people often say, yeah, but overseas everyone builds with alternative technologies. No, it's not alternative for them, it's alternative for us. In America they build with timber frame structures and cladding. Here we don't. So for us that's alternative. So then we could say there's lots of uptake overseas, but we need to look at the context. Capacity and capability of the building industry. I think I've already mentioned that because it relates to labor, there are no barriers. Maybe a bit of tweaking of skills, but there's no reason why the building industry, CIDB and so on can't pick up on alternative building technologies. There's absolutely no barrier. Education is necessary, and that's why the NHBRC has published their guidelines on how to use IBTs. We provide training and so on. So yeah, I don't think there's any barrier, and the capacity and capability is there. Portia, you asked about key benefits for the working class in terms of access and affordability. You say I spoke about time-saving benefits, but most South Africans prioritize cost saving. I hear you. For a big developer, time is money. But for me, when I want to build an extra bedroom onto my house, money is money, because I'm going to go to my local hardware store and buy the material and do it myself with my own hands. And then time isn't a factor. So I do hear you. And in that case, there are two comments that I want to make. Most of these technologies aren't available at your local hardware store. You need to go to the manufacturer and make an arrangement. And so there is a bit of a barrier there, and we're hoping to actually overcome that and help these types of products to get into our normal hardware stores. I want to go to Builders Warehouse and buy my polystyrene panel. The other comment I want to make that I just thought of around that is a question that often comes up is, can we add on to these? Because often, fine, Department of Human Settlements came and gave us 100 houses built out of polystyrene and magboard. Now I want to break through a doorway and add on a bedroom. Can I do that? Using what I have access to. And what I have access to is conventional concrete or clay bricks. You can add on. There's no reason why you can't add one wall onto another wall and tee them into each other. In some cases, the bit of a challenge might be, where do you cut that doorway? Because there might be internal structures that you don't know about. So that is another thing that we do need to address and overcome. Again, education, training, know-how is important. And back to what I started with in the first question, that community engagement. If the people who are using the building understand what's in the building, they will understand if they can build on and have access to things like that. I see there are more questions coming up here. RBTs focus on the top structure, mostly, yes. There are some solutions that provide a whole, on micro piles, sort of stilted building where the floor and the roof and everything is all in one. But generally, and what I've spoken about today is just the walling top structure. Okay. All right, are there any other questions or comments that I need to deal with?
I think, yeah, you have responded to most of the comments and the questions. So I have 15 questions, Doc, but for the sake of time, I will thank you for availing your time for this session, and also sharing your insight and experience in terms of your research that you are doing with regards to these alternative building technologies. I think it is very much appreciated from our side that you welcomed our approach. Thanks to Peha Morodu, who also then assisted in identifying and getting connecting us with you to assist us with this discussion. And maybe it's part of the response that I wanted to also advance to Don when he asked about the role that we are playing, which is one of those roles that we are playing even in this webinar, to share information that is available with regards to more of those innovative ways that are out there, which the public can then start thinking about and thinking around them. So it's part of what we do on top of the other infrastructure work that we do in terms of your infrastructure environment. So thank you very much for availing your time. And also thank you very much to everyone that has come in to participate on this webinar. We really appreciate you making time for us. I will hand back to Nobuntu to close it for us. Thank you very much.
Thank you, colleagues, and thank you, Lindo, and thank you, Dr. van Reenen, for such an insightful and engaging session. And thank you, colleagues. And then just one more thing, I would kindly remind everyone to please take time and rate this webinar for today, how it was. I've put in the link on the chat. And thank you. And also Dr. van Reenen has also put her email on chat for those that would like to have follow-up questions with her. Thank you so much. Have a great Friday further.
Thank you very much. Have a lovely day.
Bye, everybody.
Bye.
Bye.
Thank you. Bye.
Bye.
All right.